In this video, we will show how to conduct Shapiro Wilk test for normality in Python. So many of the statistical procedures are parametric tests based on the normal distribution. For example, the rationale behind hypothesis testing relies on having something that is normally distributed. So it's very important that you have to check the normal distribution assumption of the data before deciding which statistical test is appropriate. So the Shapiro Wilk test or Shapiro test is a normality test in frequentist statistics, and the null hypothesis of Shapiro test is that we assume the population is distributed normally. So if the value of p from the test is equal to or less than, for example, 0.05, then the hypothesis of normality will be rejected by the Shapiro test. And in Python, we use Shapiro function for normality test. So next we show two examples in Python. So first, we load import several module for NumPy, and from scipy.stats model import Shapiro, and from NumPy's random module import random n. So we create an array of 1000 number from normally distribute random number generate. So test data now includes 1000 numbers. So next we use Shapiro test of this test array. So you can see from the results, listed statistic is about 0.99 and the p-value is 0.42. So since this p-value is much larger than 0.05, so we does not reject the normality hypothesis. So we does not reject the null hypothesis here, which means we have not evidence that we can reject the normality hypothesis of the data. Example 2, we also import several modules, NumPy and Poisson, which we will generate data from Poisson distribution, and the seed module to create a seed, and Shapiro and RDN. So this time we create test data of array from Poisson distribution with mean 5 to 100 random number. So test data include 200 discrete random number from Poisson distribution. As Poisson distribution is not normal and is a discrete random number generated. So let's run the Shapiro test data for normality tests. So this time the test statistic is about 0.96 and the p-value is 0.000119. So it's much lower than the p-value of 0.05. So we have strong evidence to reject the normality hypothesis from this Shapiro test. Or we can say these data observations are not normally distributed. Thanks for watching.